welcome to our first video. Let's get started on some of this information. So if I have something with 0 dimensions, that would be a point. I know by drawing that point I'm giving length and width to that point, so the definition of a point is something without length or width. So we're going to use the point to indicate something with no length or width. Dimension, 1. If it's one-dimensional, we're talking about something that has length in one direction. We could call that a line that has length in one direction. It could be a line segment, it could be a ray. All those are examples of something with one dimension. Something with 2 dimensions might be something like a square, rectangle, those kind of things. It has 2 directions, has length and width. Something with 3 dimensions would be something like a cube, ball, anything in 3 dimensions has length, width, and height. 3 dimensions, length, width, and height. And then some people talk about the 4th dimension. The 4th dimension would be time, in which case that something in 3 dimensions is moving through time. The notation that we use for a line, for example, if I have a line that goes through the points A, B, that would be called line AB, and we put a line with 2 arrows above it. So the definition of that is a set of points that goes on forever, that includes A and B, but goes on forever. The arrows mean forever. Array, so if I have array AB, A is called the initial point, and notice that we only put that it's going in one direction through B forever. So definition, it goes one direction forever. And notice that it only has 1 arrow on it. A line segment, AB, means it starts at A and ends at B. So B is the terminal point. So we have an initial point at A, a terminal point at B. So it starts and stops. So it has a certain length. Has a length. Now, why can we say that a line segment has length but the other 2 don't? Well, it's because the other 2 continue on forever, and so its length would be called like infinity or something like that. Midpoint. So if I have my segment AB, and we would use M for midpoint, most of the time we use M for midpoint, and we would say that the midpoint is equidistant from both endpoints. So the midpoint is equidistant from both endpoints. Important note, well, I just asked that before. Why is it only lengths can happen in line segments? Because the others go to infinity. Can I find a midpoint on a ray or a line? No, because we don't know which infinities are bigger than other infinities. We just know that they're infinities. When we talk about length of a line segment, notice that we don't put a line above there. That means length of segment AB. Another notation that we often use is these absolute values on either side. So if you say, hey, I want to find the length of segment AB, that also means find length. So that and that mean the same thing. The absolute values means length of, and we're going to use that for other things in the future. Most of the time, I'm going to be using this notation for length of something because it's less writing. Collinear. So if we are on the same line, we are collinear, so we could say points A, B, and C are collinear because they are on the same line. Concurrent. Concurrent means that they're happening at the same time. So we could have lines that are concurrent or rays that are concurrent. So if I have could I say that line AB is the same as concurrent to line BC? Yes, because it only takes 2 letters to name a line, but there could be more than one name for that line. Let's draw this out and see if we can figure it out. You pause your video and see if you can figure it out, and then I will work it out for you. So pause now, and I'll work it out. So M is the midpoint of AB, and N is the midpoint of BM. And we know that BN is 4. So this one, since N is the midpoint of it, would also be 4. And M is the midpoint of AM and MB, so that would also be 8, the 4 plus 4. So the total length of AB would have to be 16. Hope you got that right. Locus, when a group of points satisfies a set of conditions. For instance, if I say a locus of point all equidistant from the same center point. Well, if I do that, there's a point, and a set of points equidistant from it would be a circle. Alright? So if we identified that as a circle, and could we have a locus of points equidistant from a line segment? Most of this, you would say, hey, that's equidistant, equidistant, equidistant. Then we get that one endpoint, and that's equidistant, equidistant, equidistant. And for those of you that are into sports, they would call that a track for running. If you had a line in the middle of most football fields and you measure out to those tracks, that is equidistant from a center line segment. On here we have a center, and I'm going to label my center C, and then a radius goes halfway across. So if I call my center C, I would call my radius CB, or you can call it BC. Both of them are correct names. If I drew a point right there, A, and we would call this arc AB. And notice the symbol for arc is an arc over the letters. If I put a label over here, maybe a D, we could call that a major arc, A, D, B. And the definition of a major arc is something greater than 180 degrees. And a minor arc would be less than 180 degrees. And we could use that A, B as an example of a minor arc. Notice that major arcs have 3 letters in the name, and minor arcs have 2 letters in its name. intersecting of circle and lines. What's the maximum and minimum number of times a line can intersect a circle? Well, if it intersects it, it has to run into it. Draw examples of each. So let's get to playing here. If I have a chord starts on the circle, ends on the circle. So if I label that chord AB, now notice that I'm using a segment for that. It's not the arc AB, that's the curved part of it. A diameter, we know that the diameter has to go through the center, so I'm going to label my center over here and call this DCE. So we know that our diameter, DE, is also a segment. A secant is a line, not a segment, a line that goes through the circle twice. A tangent touches the circle once. So if I had a tangent to that circle at letter E, so it touches the circle once. Alright, what is the maximum number of points of intersection of a circle and a triangle? Pause for a second and think about that. And when you're ready, come back. And I'm going to, you're back. If I have a triangle and the circle is a secant, so it hits the circle twice on each side, that means the triangle hits, or the circle hits the triangle 6 times. Alright, straight edge used to make a straight line. Hopefully you all have some kind of straight edge. Do not use freehand. Compass is used to make specific arcs, to create a line, segment XY. We're going to measure. I'm going to go up here and I'm going to make a line with my straight edge. Notice it's not the same length. And then I'm going to use my compass to measure the opening here. And I can throw an arc there to make sure that my measurement is correct. So there's my measurement. I'm going to take that and put it here. We don't use rulers. We don't use rulers to measure stuff. We use compasses to make the same length. So I'm going to label this XY. Alright. If I want to create a line QP that is twice the length of the original CP, again, I'm going to start with a line that I used my straight edge for, and I'm going to take my compass and I'm going to measure that length. I have that length, and then I'm going to mark it off once, and I'm going to go to the end point there and mark it off again. So now my QP, they said to draw QP, there's my Q, there's my, no, that's not a P. My QP is that length, twice as long as CD. Okay? Alright, well, I'm going to start on the next slide on the next video. Alright, thank you.